Hi, this is Muri reporting from Berlin, and this is part 7 of my using React hooks with D3 series. And in this one, I want to show you how to create this chart right here. It's a gauge or a pie chart. And the special thing about it is that it will take its data from a machine learning model, which I trained to tell you basically if I'm there or not. So the gauge will be full like this if I'm here in front of the webcam, and it will be empty if I move away like this. So full, empty, and full again. And it will also be empty if I cover my eyes like this. So it will be animated, and it will use something called Teachable Machine and ML5. So stay tuned. So like I said, I use Teachable Machine for this. It's a Google product where you can like teach a machine, create a machine learning model for free. And yeah, I went here and created an image project. And yeah, I used two classes, one class for if I'm there and one class for if I'm not there. So I said here webcam, hi, and I basically created samples for the machine when I'm there like this. And then I created samples for the machine if I'm not there. So oops, like this and like this basically. And then I train the model, takes a little while. Freeze. Yeah, then now it's training the model. And what you have to do is export the model when it is done. Let's wait here a second. Yeah, you can see basically, I can see a preview of how it would behave. And yeah, I exported this model, I said download, and I unpacked this zip file you get from here in the public folder of my Create React app. So like I said in the first video, I am using Create React app, and there's always this public folder. And I just unzipped the model in here. So yeah, this video will focus on the gauge or the pie chart here in this case, but I will also quickly explain how I am using Teachable Machine and ML5 for this setup here. Yeah, so in my app, I'm using ML5. I installed it. It's a machine learning library. And what I'm basically doing in my app is when it has started up, when the DOM elements have been rendered, in UseEffect, I'm telling ML5 to load my image classifier, which is basically the model I unzipped in the public folder I just mentioned earlier. And when this model is ready, this callback will be triggered. And in this callback, I'm basically accessing the video or webcam of the user and connecting the webcam with the video element I have defined also down here in my app component. And then basically this use interval hook, it's actually also a custom hook. It is basically a set interval which every 500 milliseconds will try to classify what is inside the video element currently and tell me if I'm there or not. So, and this data I am then saving in with this function here, set a gauge data, and passing it to the gauge chart down here. So a quick note about this use interval here. Use interval is a custom React hook which basically calls this function I have defined here every 500 milliseconds. And it works very similar to set interval, but yeah, using set interval in React or with functional components is not that easy. And that is basically why I copied the entire custom React hook from the article of Dan Abramov. You can find it down here. So one more important thing to note about this use interval hook right here. I am basically classifying the input of that video element every 500 milliseconds with ML5. And when this classification is done, I'm getting a results array. And this results array has two things. It tells me how confident the machine is that I'm there, and it tells me how confident it is that I'm not there. And these two elements, or this result array, is sorted by confidence. So the first element in that results array will always have the higher confidence, and this is something we don't want for our like gauge or pie chart right here. So that's why I'm just sorting the results by the label basically, and so that they don't change depending on the confidence. Yeah, so now we'll be rebuilding our gauge chart I've shown earlier. And for that, I basically removed everything except some of the basic things which I've been using in the, like since lesson 1. I'm still using useEffect, for example, to access the SVG element down here to work with D3. I'm still using the use resize observer hook we created the last time to have a responsive chart component. And yeah, that's basically our boilerplate gauge chart component. And what I've also done is I updated the headline here. I am now showing the confidence levels the machine learning model basically returns to me. And this is the array we are passing to our gauge chart. And yeah, this is what we need to work with to create the gauge we have seen earlier. So to render the gauge, we have to understand that the gauge was split in two. There was this yellow part, and then there was this gray part. And basically, that was a representation of each value in the data array we got from the machine learning model. And yeah, what we basically need to do first is we have to render two path elements, one for each element in this data array. And to do that, we have to say, like the normal general update pattern from lesson 1, SVG, select all elements which have the class slice and synchronize them with the data I'm giving here, the data array I'm receiving from the outside. And then I'm going to say join, so basically create a new path element for every new piece of data, and then also attach the attribute class slice to every new or updating element. So if I save this, you will see now I have two path elements, which now I have to basically shape like a gauge. So as you might remember from one of my last sessions, the path element or the shape of a path element is defined by the attribute D, like this. And the D attribute is where you define where it basically starts, how it's shaped, and so on. And what we now need to do is we have to attach this D attribute to each of our slices on our gauge. And the challenge is basically to attach these D attributes to these slices while also making sure that they kind of belong to the same gauge and belong to the same arc. And this is basically where D3 comes in. D3 has helper methods which basically allow you to create this arc and split it into like multiple slices, and then we can extract the D attribute of these slices and attach it to our path elements. So in order to define the D attributes of each slice on our gauge, we first need to create an arc, which we then need to split into multiple segments with D3, and from these segments we can derive the D attribute. And for that we need to import two things from D3. The first thing is called arc, which will create this arc for us. And then we also need to import something called pi. And pi is really cool because it what it basically does is it transforms the data we have, like here, into instructions for the arc, so that the arc can basically know at which angle it needs to split the arc into multiple like slices. Yeah, that's basically it. So now let's make use of these two new imports. I will start with the arc element. I will say const arc generator, because the arc function actually returns a generator which will then create the arc for us. And here I have to define two things: the inner radius, which is going to be 75, and the outer radius, 150. And this is it for the arc generator. And then I have to define a pi generator, which works similarly. I just have to say pi for now. And let me show you how this pi generator works. I will first log out the data I have, and then I will log out the data which gets transformed by the pi generator like this. If I save this, you can see this is the data I'm getting from the outside, and these are the instructions for the arc. And you don't have to understand everything right now, but it basically tells at which angle it starts the slice and at which angle it basically ends. And yeah, let's make use of this now. So instead of using the raw data we have defined here from the outside to render our slices, we need to make use of the pi generator, or we need to make use of the instructions the pi generator returns. So I will just write it in another variable to make it more clear. I'll say instructions equals pi generator and delete these. Then I'm going to pass these instructions to the data function here instead. And now I need to make sure that these each instruction is passed to the arc generator, which will generate the D attributes of our slices. So now I can just say, I can pass a callback function here, which receives like an individual instruction, like so, as an argument, instruction. And I can pass the instruction to the arc generator like so. And before I save this, I know that I have to do some small styling things here to make it more visible. I have to say stroke black and utter fill none. So let's save this and see how this looks like. So I also went ahead and added some styling to center this whole thing here. It was on the top left corner. But yeah, this is how it looks like. We have an arc, like a whole circle in this case, and we have two slices, 50-50. And if I were to start classifying here, you can actually see that the arc is divided into these slices depending on the data we are receiving from the outside. That's already pretty cool. So now I will quickly add the colors to the slices. I will for that say instruction index and look at the index. I'll say is the index 0, then I will return this nice yellow here, and if not, I want this like gray. Save this. Yeah, looks fine. And I also just remove the stroke, which I didn't have earlier either. There we go. So now let's turn this thing into a half circle like it was before, and for that we actually need to apply some math. Yeah, we have to go to the pi function here, and we have to say the start angle is going to be negative 0.5 times math pi, and the end angle is going to be positive 0.5 times math dot pi. So I'm not going to explain this in like rich detail, but the only thing you need to know is one math pi is one like half circle, and the arc usually starts here at the top. So negative 0.5 math pi is saying the start angle is like a quarter circle to the left, and the end angle is a quarter circle to the right. This is everything it does, and yeah. Yeah, so now if I start classifying with this half circle here, you will notice something odd. If I move away here to reduce the confidence, you'll notice that the like yellow part shifts to the right side sometimes. That is also because the pi generator or the pi function here sorts these instructions like by value we are passing here to the data array. So in order to stop that, we have to say sort, oops, we have to say sort null. And let's see how this looks like. start classifying. You can then see that the yellow segment behaves correctly. Cool. So now for the hardest part of this video, the animation of these slices here. And in former videos, we could always just say dot transition, and everything which basically comes after these this transition call will be animated. This works for like numerical values or like simple values, but it doesn't really work for the D attribute, for example, because the D attribute is a very complex string, and yeah, that's why it doesn't really work. But still, there's a way to animate these slices. So this is how it looks like when I just add the transition before the enter. You can see it behaves very, very weirdly. So to animate this D attribute, we actually now have to use something called Tween. A tween is like a transition over time, and yeah, what we need to do is not return this D attribute or this hard string value in this callback function, but we actually have to return another function. So I'm gonna rewrite this function like this: function instruction, and we have to return another function. And this function will receive an argument called t. I will explain what it is in a second. So for Tween, we have defined a function that receives the current instruction of our instructions array here, and we have defined a function we're returning with the argument t, and the t stands for the current timing or the current state of the transition that is going on. And the t argument can be something between 0 and 1, and 0 means the transition or the tween has just started, and 1 means the transition is over. And D3 will call this function over and over again with t0 and then t0.1, t0.2, and so on. And with each like timing, we have to basically tell D3 how to set our D attribute. We have to tell D3 how to set our D attribute over time, because it cannot manually figure out the calculations of the D attribute. So at this Tween function, we have to do something called an interpolation. And the way it works is like this. We need to know what is the last known instruction for the arc and what is the next instruction for the arc. And these instructions, they are objects basically telling where the start and end angle of each slice is and so on. And we basically need to animate from this old instruction object to this new instruction object. And so basically we need to animate all of the properties from left to right over time. And to do that, we have to use something called interpolate from D3, which basically animates all of the properties of an object over time. And to use that, we have to say const interpolator equals interpolate some last instruction, I'm going to call it, and the next instruction. And the next instruction is actually the instruction I'm going to receive here in this callback function. So that's why I'm going to just rename the argument. And yeah, imagine now I knew the last instruction. Then the interpolator I have here would work like this. The interpolator is also a function which we can call with something between 0 and 1. And if I call it with 0, it will basically return the last instruction. But if I call it with 1, it will return the next instruction. And if I call it with something in the middle, like 0.5, it will also return something in the middle. It will animate or interpolate all of these properties in this instruction object. So this is what we need to use in this t function, because t is also a value between 0 and 1, like describing the current state of the transition. So this function here needs to set the d attribute of our path element, and instead of returning the arc generator like we did earlier with the next instruction, we now need to use this interpolator instead. We have to say, don't just give me the next instruction, but give me an instruction over time. And for that I have to say interpolator t with the current timing of the transition. So now about the last instruction object we have defined here. We can actually not know about the last instruction unless we had an instruction. But what we can do is we can prepare the last instruction for the next time our gauge updates, and for that we have to say last instruction equals interpolator 1. So what this basically does is it tells D3 to pick up the next interpolation or the next update where the last update has finished. And now we still have the problem that we didn't store the last instruction for each slice or for the arc yet, and what we can do to fix that is we can use this keyword, and this is why I was using this syntax for defining a function, because if I'm using an arrow function it doesn't work that way. And if I now save this and start classifying, you will see that the animation will work properly. So I know it is very, very complicated. If you have any questions about this, please let me know. So this keyword in this case refers to the path element, and what we're doing is basically we're saving the last instruction for each slice or for each path element on the path element itself. And one thing you might also have noticed is that this is empty for the very first time this Tween function is called, and that is true, but it is no problem for interpolate, because if it is undefined it will just use the next instruction object and there will be no animation, as you can see here if I reload the page. Yeah, so that's it for this video, and yeah, I hope you enjoyed it. I hope you learned something or two about machine learning, teachable machine, and D3. And I know this stuff can seem very hard and intimidating, but I assure you, if I got this, you can get it too. So yeah, see you next time.